Welcome learners, both old and new students. You are most welcome. This is Black Slides Online Secondary School. We are on YouTube as well as in the main online platform. Where you are found depends on it's your choice. If all you want is to watch these videos, lessons for free here on YouTube, that's okay. You can do that. All you have to do is subscribe to the channel and also remember to hit the notification bell. That has an advantage of having or being notified each time I post a new video lesson. But if you need one-on-one lessons, consider enrolling for our online lessons where you can take a number of subjects at a go. We are going to help you achieve your dream grades, MSCE grades. Remember that at the Black Slides we intend to produce as many distinctions as possible. That's our goal at the Black Slides. Alright, we don't stop at anything less than a distinction. So we are going to mentor you, to prepare you, to give you the materials that you need to study to prepare for your MSc exams in 2026, or if you're in Form 3 in 2027. So once again, you are most welcome. Without further delay, we meet now for a lesson in Form 4 Physics on a topic called turning effects of forces. Turning effects of forces. In Form 1 Physics, you learned that forces have different effects. Alright, a force can cause a body to stop moving or to decelerate. Alright, a force can cause a moving body to accelerate or to move faster. A force can cause a body to change its shape. Forces have numerous effects. Alright, so one of the effects of forces is called the turning effect of forces. The turning effect of forces. That's the topic of the day, the lesson of the day. Alright, so by the end of this topic, we expect you to be able to do the following things. So we are saying by the end of this lesson, or rather topic, you should be able to define the term moment of a force, alright, and also be able to state the SI unit of moment of a force, be able to state the principle of moments. You should be able to state the principle of moments. You should be able to state the conditions for a body to be in equilibrium or in a balanced state. Equilibrium means to be balanced. Alright, so when a body is balanced, we say it is in equilibrium. If such a body is not turning. Alright, so what are the conditions required for a body to be in a state of equilibrium, or for a body to be balanced? Alright, so we shall also define the term center of mass, also known as center of gravity, center of mass or center of gravity. Alright, we shall describe an experiment to determine the center of gravity of an experiment to determine the center of gravity of a regular body such as a lamina. Remember, a lamina is a flat body. Let's say we have something like this, like a cardboard paper. A cardboard from carton, you cut out a carton of this shape, and then you want to determine where it is going to be balanced, where such a body is going to be balanced. We shall also describe an experiment that could be done to determine the center of mass or center of gravity of an irregular shape. An irregular shape such as this one. Right, suppose you cut out something like this from a cardboard, so you want to determine where it is going to be balanced. Okay, so we shall describe an experiment to show how this can be done. All right. Okay, we shall also go on to look at the applications. Applications of the principle of moments. We shall describe experiments to determine the mass of a uniform body. Alright, we shall describe experiments to determine the mass or weight of an object using our knowledge of turning effects. Alright, we shall also define the terms stability and equilibrium, as well as types of equilibrium, factors which determine the types of equilibrium, and last but not least, we shall discuss how to make a body stable. How to make a body stable. Alright, I hope so far so good. If you are a new student, you have just joined the YouTube channel, you have visited this channel for the first time, let me welcome you in a special way. Welcome. Consider subscribing to the channel so that every time we post a new video lesson, you become the first one to be notified. You will become the first one to be notified. Welcome, learners, to the channel. And in case you'd like to enroll for online lessons, don't hesitate to do that. All you have to do is contact me on the number 088-434-1022, or you can do that on 098-125-8577. These are the numbers you can reach me on. It is going to be good for you to contact me so that we can arrange lessons for you. Alright, so my name once again is Mr. Paul Chilola. In everyday life, we see effects of forces, turning effects of forces. In everyday life, we see turning effects of forces, namely, for example, opening or closing a door, window, a lid of a container, for example, a jerry can. You see forces causing things to turn. Yeah, even turning on a tap, you want to get water from a tap, you have to apply a force. Such a force is going to cause the tap to turn, and then water comes out. Alright? Turning effects of forces are seen in doing or undoing a nut using a spanner. Let's suppose, for example, you have a nut to be undone. Alright, so you have to use a spanner to do that. So this is a spanner. Alright, you shall need to apply a force. Depending on what you intend to do to the nut, you either apply a force there, force F, alright, or apply a force upwards. Alright, so it will cause the nut to turn. We've seen the turning effect of forces in kids playing on a seesaw. I'm sure you have seen kids playing on a seesaw, or if you have not seen, at least you have played on a seesaw before. Alright. So in a seesaw, you usually have two kids. You have two kids sitting on opposite sides of a bar. Alright, so when one child pushes this down, and the other child will go up. Okay, in so doing, there is a turning effect of forces. And many other examples you can think of. Turning effect of forces. The extent to which a body turns depends on two main factors. Alright, we call them factors determining the effect of turning force. Alright, what are the factors that determine the size? The size, Yeah, this should be determining the size or magnitude, determining the magnitude or the size of a turning effect, a turning force. Alright? So what are the factors that determine the effect, a turning effect, the magnitude? This needs to be corrected. Determining the size of a turning force. So, principally there are two factors. There are two factors that determine the effect, the turning effect, the effect of a turning force. Alright? Let's suppose we have a body which is supported somewhere, a body that is supported somewhere here so that it can turn. Alright? So to cause this to turn, a force needs to be applied, whether downwards or upwards. If a force is exerted downwards, it will cause this to turn in a manner which is called clockwise direction, or if you push this up, it means it will turn in an anti-clockwise direction. Alright, so what determines the size of the turning effect? Alright, so the size of the turning effect of such a body depends on the magnitude of a force. The bigger the force exerted, the greater would be the turning effect. In other words, when a large force is applied, the body is going to turn more. Another factor is the perpendicular distance from the line of action of the force to the pivot. The pivot is the point about which something turns. Alright, so the distance from the pivot, this distance here, is a deciding factor as to how much it is going to turn. Alright, let's suppose you apply a force here. If you apply a force there, it will be observed that the the beam or the object does not turn that much. All right? And if you keep moving shifting from the pivot, let's say this time you apply a force here, you appreciate that the body turns more than when the force was applied close to the pivot. The further you move away from the pivot, the greater would be the turning effect. The further you move away from the pivot, the further the force is applied from the pivot, the greater would be the turning effect. So the combined effect of these factors is what is called the moment of a force. Moment of a force. Of course, the word moment is used in a different context to mean something else. For example, you have seen the word moment being used to mean space in time. For example, you say, at this moment, would like us to have classwork. All right, it means you are talking about at that time or juncture. But here, strictly speaking, we are not using the word moment to mean time, but we are using the word moment to mean the product definition of moment. Define the term moment. Suppose your teacher or your examiner asks you to define the term moment. So what is moment? Moment. Definition of moment. Moment of a force, All right. We shall define moment of a force we are going to define moment of a force about a point as the product of a force and the perpendicular distance from the line of action to the point, in this case to the pivot. Right, let me enlarge this a bit for the benefit of my students. All right, so we are saying that the definition of moment, the term moment is the product. Product means multiply. So you take a force multiplied by the perpendicular distance from the line of action of the force. Let's say, for example, we have a body such as this, which is pivoted somewhere. Okay, pivoted means it can be made to turn about that particular point. All right. Then for us to have a turning effect, we must apply a force somewhere here. All right. So there's a distance from the turning point D to the line of action of a force. So moment, therefore, definition of moment, let's say a moment is M, is simply the force applied multiplied by the distance from the pivot. This distance must be perpendicular to the line of action of a force. So this angle here must be 90 degrees perpendicular. All right, so that's what we have. Now, since we are multiplying, we are finding moment as force multiplied by distance. That means the unit of the unit of moment is going to be the unit of force, which is Newton, multiplied by the unit of distance, which is the meter. Okay, they will ask you in an exam, state the SI unit of moment. It is just the Newton meter. In short, you write Nm. Alright, you have to be careful. This Newton meter is not the same as that of the unit of work done. Remember that work done is also given in Newton meters. Okay, but we go on to say the SI unit of work, the SI unit of work done is simply the Joule. Alright, so when you obtain your work done in Newton meter, remember to convert it in joules. So if you are calculating work, you stop on joules. If you are calculating moment of a force, you stop on Newton meters. Alright, I hope we are together there. We have defined moment of a force as simply the multiplication, the product of a force, and the perpendicular distance from the line of action of the force to the point. This distance here multiplied by the force applied. It will give us the moment of a force. Alright. Unless you have questions, if you are new to the channel, consider subscribing to the channel and also hitting the notification bell so that you don't miss our future videos. Alright, as an example, consider the diagram shown here. So we have a diagram in the figure below in which a uniform ruler is balanced on the edge of a knife at its center. Alright, so we have a ruler which is balanced. This is just a ruler. Balanced means that it's not turning. It's not turning on its own. It's not turning clockwise or anti-clockwise. Such a ruler is said to be balanced. Alright, so we have a pivot here. That's the point about which the ruler is going to turn if a force is exerted at any point. Alright, that's very important to note. Okay, and then we have two forces, F1 and the F2. Okay, depends. If we exert a force F1, it means the ruler is going to turn this way. If the force F2 is exerted, the ruler is going to turn in the anti-clockwise direction. So the moment about the pivot, in reference to the diagram, the moment about the pivot due to forces F1 and F2 is got or obtained by using the following formula. Alright, pay attention. So moment is simply equal to force multiplied by perpendicular distance from the pivot to the line of action of the force. Line of action in this case is this point here. This line is called line of action. So the distance we are referring to is the distance from the turning point. The whole of this distance is called the perpendicular distance. It must be at 90 degrees. Similarly, there is also a distance which is labeled x, which must be perpendicular to the line of force there. So moment, therefore, is force multiplied by perpendicular distance. So moment due to force F1 is going to be the magnitude of F1 multiplied by the distance y. So since we are multiplying force by distance, the unit is going to be Newton meter. The direction is going to be clockwise, clockwise, clockwise. All right, that's very, very important. Moment about F due to F2 is also going to be found by multiplying F2, force F2, force F2 multiplied by x. So you take this force here multiplied by x. It will give us moment about that direction in the anti-clockwise direction. All right. So if the two moments are equal, then it means that F1 times y is equal to F1. This must be F2. F2 times x. Then the body is said to be in an equilibrium state. And this statement is called the principle of moments. All right, so what is the principle of moments? What does it say? What does the principle of moments state? Is a statement. All right, the principle of moments states that when a body is in equilibrium, the sum of clockwise moments about any point is equal to the sum of the anti-clockwise moments about the same point. Or if you forget to say this whole statement, just say that the sum of clockwise moments equals to the sum of anti-clockwise moments. So basically that's what moment is and what the principle of moments states. Make sure you are able to state the principle of moments in your own words without changing the meaning. Make sure you know the principle in full, because your examiners will require you to state it like this. All right. So try to be creative to state the principle without changing its meaning, but being able to state it in your own words, All right, so I would like us to